Talk up by Zach Miller talking about the importance of NLP, importance of pipelines in NLP.
Okay, can you guys hear me? Yes, no? Good, okay. Hey, so yeah, like you said, my name's Zach, and I'm gonna be talking about the importance of pipelines in NLP and how we should think about them. And if I'm being honest, the previous talk stole like half of my thunder. So we're gonna see how this goes. So this is the title that I gave so that I would get into the conference. This is the title that I wish I could have given to get into the conference. I love/hate NLP and it should suck less. So let's talk, I think it's important to kind of set who I am and to give you sort of expectations for this talk. One, I'm a physicist that kind of went rogue. I basically got sick of academia and was like, I can't do this anymore. And that means that I came into computer science and data science with no computer science background, like none. So a lot of the things that I'm going to talk about are things that I learned while I was realizing that computer science doesn't have to be the worst experience of my life. But I am uncomfortably into numeric optimization and talking about gradient descent. So I also don't have an NLP background. Like, language is not my forte. So like whatever the opposite of the grammar police is, that's me. Like you could barely speak English to me and I'd be like, that's great, it's fine, I don't care. So when I start doing NLP, like I'm not coming at this looking for technical reports or anything. And so the last thing that I think is important is that I'm a person who loves repeatable processes. I want to be able to come in and say, I give you this data, I get this thing out. And that is the opposite of NLP as well. So realistically what I am is a non-NLP expert who does natural language processing sometimes, but really hates the process of doing natural language processing. Like I loathe it. It's my least favorite thing about being a data scientist. So that's where I'm coming from. And so the problems that I see with NLP basically come down to this. Machine learning is what I want to do, and it only likes numbers. Words aren't numbers, and the process for turning words into numbers is much more art than science. So when I start making choices at the top of my pipeline, what happens downstream is not apparent. I can't just say, well, I tweaked this, and therefore this is going to happen. So that's basically what we're going to be digging into today is how do I make that suck less? So since I'm going after an NLP talk, this is going to be kind of redundant, but we're going to do it anyway because I budgeted for 25 minutes and we're going to do this. So I'm going to give you sort of a high-level NLP like view of what we're going to do for machine learning. So we're going to start with some document, and then we basically have the feature extraction steps that Justin was just talking about. So we're going to have some tokenizer, something that says, you know what, we can't treat this as a big block of text. I need to look at this at a word level or some subsection level. So that's what my tokenizer is going to do. I'm then going to throw it into some sort of cleaner that says, okay, this type of word can't handle this. I can't handle punctuation. I need to do this, this, and this to make my text useful. And then finally, I might throw it into some stemming or limmatizing or something along those lines. So meaning, well, we'll just get to that in a second. So basically, this functions as my data preparation or my feature extraction part. And this part is basically the be-all, end-all. Like this, if I do this wrong, nothing else matters. And so there's going to be a lot of work on this side. And in particular, there's a lot of work because there's a lot of ways you can do this. So let's start with this sentence. I'm from Chicago. I've spent the last several years hating and loving natural language processing. So if I start with this and I throw it into a tokenizer, let's just start with a simple one where I break on spaces. Okay, so now all of these words become individual pieces that I can build upon. But there's not just one way to tokenize, right? So I could then say, well, all of these contractions are something that I don't want to deal with. So a different tokenizer might say, cool, let's break those apart. I'm going to have some lookup dictionary. I'm going to break those apart. And I'm going to go from I'm to I am and I've to I have. And so now I have two choices of tokenizer, right? So I've got one here where I don't do this, one where I do this. There's 30 other choices that I can make. Let's stick with two for now. Okay. Now for cleaning, I can go from capital I and like lowercase everything, and that becomes my, my choice for cleaning. But there's another choice I could make where I remove punctuation. There's a choice I could make where I don't remove punctuation. There's a ton of ways you can go with that. For stemming, I could choose to convert like the am and have into be and has so that I'm more consistent. Because consistency across my data, if I want to understand the words, is going to be very, very important. It's that reducing noise step of trying to make my pipeline work. And I could take things like process from processing and all of those steps. There's just so many choices that you can make. Stemmer 2 might say, you know what, instead of hating and loving, I'll say hate and love. So there's, again, like I just want to impress upon you, there's tons of choices being made, and I'm only 3 steps into my pipeline. So I haven't even really gotten to a point yet where I can decide, is it working or not? And I've already made like 20 choices. So the next step would be, let's go from my data prep to converting to numeric. So to do that, I'm going to do a couple more steps, which is remove some stop words. I'm going to do some named entity recognition, and then I'm going to do some vectorization. So these guys, again, it's not exhaustive, but this is kind of like the steps that I might take. And what that does then is I can go from this sentence and take out all of the words that are common, that aren't giving me a lot of information. So I, be, from, and I have. That's junk, essentially, right? That's noise. The word and conveys nothing to me. So maybe I take those out and I end up with this sentence. Chicago spent past several years hate, love, natural language processing. Now, depending on my cleaner, I may have process or I may have processing. I may have different punctuation. I may have different words split out. There's tons of variables here. I could also get even more fancy and say, you know what, my stop words, maybe I need some domain-specific stop words, so I'm going to take those out as well. So there's some more choices. For named entity recognition, I can do things like removing Chicago and replacing it with generic city, so that I know that in my pipeline, I don't necessarily care that it's Chicago or New York or whatever, it's just city name. And so that's one choice I can make for named entity recognition, or maybe I do something where I make another choice, which is take New York and make it new _ York, so that I understand that I'm talking about the block of New York, not the words new and York. So again, more choices. And then finally, for vectorization, maybe I just count the words, or maybe I normalize it and scale it. There's more choices. Okay? So I've said choices a lot, so let's move on. So after I've done all of this, after I've got my data to numbers, that's when I can start making choices about the actual modeling and the machine learning. So up until here, I haven't even done anything, let's call it useful yet. I haven't said, you know what, I have an end goal of making this prediction. Nothing has happened yet that leads me to that. All I've done is said my data is terrible. How do I make it less terrible? And that's the entire first 6 steps. Okay? So if we draw this out in a somewhat suggestive format, we can look and say, you know what, let's keep it simple. We'll say, let's look through 3 tokenizers, 2 cleaners, 3 stemmers, 4 different sets of stop words, 2 different sets of named entities, and 2 vectorizer methods. This is not particularly exhaustive. This is just hey, I might find these. You could find all of this in scikit-learn, just this many examples kind of thing. So because I've drawn it suggestively, you may already be putting these lines in, but if I draw these lines, there's now 36 unique combinations of ways that I could explore my data before I even get to any modeling choices. Right? This is just pre-processing. And so if I look at this and I say, you know what, I want to know what the best choices to be made are, it's not clear because A, this is a very interconnected system, and B, each choice has really big downstream effects. So if I say go to this tokenizer and I say, you know what, I'm just going to hold everything else constant and switch this tokenizer and see what the result is, that's not going to tell me anything because the choice of tokenizer here may change how my named entity recognizer works. So this highly interconnected system is now a problem for me that I need to try to solve. And so basically at this point, I've complained a lot about NLP. That's what we've accomplished so far. So let me talk about some possible solutions. So I guess the most naive or simplistic solution is to basically take the this is my rifle creed and apply it to your NLP pipeline and say, I will only ever use these pieces and I'm going to learn these pieces inside and out until I can no longer learn anything new about them. So for instance, I might choose this tokenizer and this cleaner and this stemmer. And what I can do then is really focus in and say, I know exactly how changes in this tokenizer are going to change the behavior of my stop words or my limitizer. So as I study those interconnected pieces, I can really get a sense of how to use my pipeline for what I want it to do. But the sort of the downside to that is something that we're also going to have to confront here shortly. Now, I'm showing you this as a why not just do this, which means that I'm leading you to the conclusion that you probably shouldn't. But I will say that most people do. So like this is not a bad solution by any stretch of the imagination, and I know that because that's what all of these do, right? And they're way smarter than I am. So like I'm not saying they're wrong, I'm not saying it's a bad approach, I'm saying we may want to consider some other approaches because pipelines shouldn't be inflexible, right? So like when you look at these guys, like TextBlob just takes a bunch of stuff from NLTK and says, these are what I'm choosing. This is the thing. You give me your text, I give you the thing back out. Spacy does the same thing, but it does it in a way faster and more enterprisable way. GenSim does something similar, and Stanford's group does something similar, but in Java, so it's also faster. So they basically have said, you know what, there's too many choices. We're just going to make one pipeline that works pretty well across everything, and we're going to make it super fast. And that's really not a bad choice, but there are other approaches, and that's what we're going to talk about now. Okay? So the reason that that could be a bad choice is basically comes down to this, right? The Fellowship of the Ring is not equivalent to a chicken Caesar salad sounds so good right now. Okay? So if I'm applying my pipeline to, say, Tolkien, right, I can't expect that same pipeline is going to work just as well on Twitter data, because Twitter data is inherently incomprehensible. Like, you can't just say, you know what, I'm going to throw out certain words because they're common in Tolkien and then apply that over here on Twitter, right? Because, as an example, like, the word therefore is going to show up in Tolkien a lot, right? If someone uses the word therefore on Twitter, they have a real message to get out there to you. Like, they mean something when they say therefore. Twitter just uses it, or Tolkien just uses it because it's a filler word. So those differences are important, and you can't expect your pipelines to necessarily work across that. So instead of choosing to take one pipeline and really dig down deep into learning it, what we're going to do instead is we're going to look at how can we take sort of the really flexible tools that NLTK and scikit-learn give us and try to make that something that is usable because I don't have to make a ton of choices. Well, I do, but when I make them, it kind of does it for me. So the way that I've done this for a lot of my life is like this. And if this doesn't make you sad, you've never done an NLP project. So what I did would be like, hey, I'm going to apply this thing to this text, and I'm going to store this here. Cool, now I'm going to apply this thing to this text and store this here. Well, now I'm going to take the output of this thing and put it through all of the different tokenizers that I have, and I'm going to store those. And by the end, I've got 65 different variables storing 65 different solutions to one problem, and it's a mess. So eventually, after probably a year of doing this, which is sort of indefensible on my part, I decided that maybe I should try to come up with a more useful way to approach this problem. And so what I'm going to present now is a naive but workable solution to this problem with the large caveat that I know this is not the best solution, but it does inform how we might think about these solutions going forward. So what do we actually need from our solution? So when I kind of laid this problem out, I said that we kind of want to be able to try all of the different things because depending on our data set, different things are going to work better. So instead of just picking one, what I want to be able to do is pick a set of choices, plug them into some API somewhere, and then never have to think about it again until I look at what the behavior is. I don't care about the internal workings of how this piece talks to this piece. I want to write that one time, abstract that away so I can actually think about what the pipeline is doing. And so that's what we're going to try to build. So with that sort of in mind, let me walk through the code with the note that the code really doesn't matter here. Like, I'm using this as a backdrop for how we're thinking about the data flow. Don't worry if it doesn't necessarily make sense or don't get like lost in trying to read it. So what we're going to do is we're basically going to create a class that's going to hold all of the data flow for us. We don't care what pieces get slotted in. We just want it to handle the data going from one end to the other. And so I might do something like, hey, let me put in a nice little vectorizer here. Let me hand off a tokenizer. Let me hand off a cleaner. Let me hand off a stemmer. And when I hand those off to you, I want you to just know what to do with them and continue to pass those down the chain as you go. So in order to sort of manage that, what we're going to do is we're going to store all of these pieces as attributes inside of our data pipeline piece. Okay? And then what we can do is we can provide like sort of baseline things where the data comes in and the data always comes out. It's sort of a functional style of programming here. So other than the fact that we're storing these pieces, the actual data flow is just going to be top to bottom, and then let's look at the output. So I might have some very simple tokenizer here that just splits on spaces. It doesn't do anything smart. But I could also have a different example where I pass in a tokenizer that says, you know what, do something smart. Break down contractions. Break down anything that you want. All that I care about is that when I hand you the text, you return to me the text split into pieces the way that you want to do it. Okay? So our pipeline isn't necessarily going to be something where we where we need to control everything. The only thing we really need to control is that when we're doing our NLP, we just need to make sure that the pieces talk together. And as long as we're sort of conscientious about that, that can come out. The next step might be something like a base cleaning of the text. So maybe I say, you know what, give me my text. I'm going to tokenize it. I'm going to lowercase it. I'm going to stem it. I'm going to do all these other things with it. And then when I'm done, I'm just going to pass that back out so that whatever flow I have, it's always continuing down the waterfall. And then sort of the key piece is that we're going to abstract away all of the challenges of maintaining everything, okay? So what we're going to do then is basically just write some kind of, I'm stealing this API from SkLearn because they're smarter than me. So I'm just going to say, you know what, whatever my pipeline is doing, when I say fit, I want you to go ahead and run through and do all of this. I want you to clean things. I want you to learn from the data what you need to learn. I want you to learn the pre-processing. I want you to do whatever you need to do to make sure that when I later ask you to clean up my documents, I can say, hey, go clean, and it just spits back a document that's clean. Okay? So that comes out of my fit function, and then my transform function down here is basically the other side of that piece, which is when I get ready to use you, I don't want to have to think about what to do. I just want to say, do the thing. Right? So this is, again, abstracting away all of that messiness and saying, do the thing. And so what using this looks like now is instead of that mess that I started with, which was like 25 lines of measuring things and keeping track of them, is now I just say, hey, I would like to pre-process. Please learn from my corpus. Now tell me what you learned. Okay, so there's 3 lines of code hiding all of these different choices, because I can slot in a Porter stemmer or a Lancaster stemmer or whatever limitizer I want, as long as I slot them in carefully. So basically what we've accomplished so far is we've given our pieces a nice house to live in. Right? Like I've got all these choices that I'm making, and all this really does is say, cool, here's a bucket, nice bucket. Right? And now that bucket says, when I say fit or transform it, it does everything in the bucket, but it doesn't really take away a lot of the challenge, which is this. Right? I still, if I want to try 25 different pipelines, I've still got 25 different variables floating around. So I've made my problem look a little bit nicer, but I haven't really solved my problem yet, because it still falls to the user to keep track of everything that's happening, which is what we were trying to fix in the first place. So there's sort of a next step, which is, what if I make this something that is basically transient? Okay? So I don't want to store in memory all of these different pipelines and manage them. What I can do instead is set up each pipeline and then throw it out to a file until I'm ready to use it. Right? So now these pipelines become individual pieces that can be picked up and slotted in wherever I want them to go. So it's essentially Docker containers, but for weaklings like myself that can't handle Docker containers yet. Right? So like, this becomes just, if I can save all of those pieces and in their trained state, all I have to do is load the piece that I want, run things through it, and then take it back out of play. And so what this does is it basically opens that up to me. So it goes through and it says, you know what? Whenever you figure out what you want to do, like let's say I'm trying 25 different pipelines, I'm going to construct that pipeline, I'm going to initialize it, and then I'm just going to dump it to file, and then I'm going to give myself an option to load it back from file. Okay, so then what that allows me to do is something that looks like this. So these are kind of the 2 parts of managing your pipelines if you're thinking about it in this way. One is you construct all of the pipelines and you just dump them to file. And then whenever you're ready to use them, all you have to do is say, look up every pipeline that I've ever created, and now go do the transformation with them. Okay? So now instead of having all of this mess of files to keep track of and memory to manage and things like that, everything is just dumped to my hard drive, and then as I load, I can load the pieces as I want them and do whatever I want with them. So I can load, if I've got 25 models, I'm going to load 25 models and then pull data out of it and see how it does. Okay? So that's the pre-processing side of things. That leads us to sort of the next step, which is now let's actually use this to solve a problem. And what this does for us is it basically takes us back to non-NLP machine learning. So I think a lot of us that got into NLP sort of late in the game understand the machine learning side of things way better than the NLP side of things. At least that's true for myself. And so if I can get to a point where I'm doing the machine learning side of things without having to think about the NLP so much, that becomes a very valuable thing because that makes me way more efficient. And so that's sort of what this does, which is it basically says, you know what, maybe we'll just make this model wrap around a pre-processing pipeline. So I hand you whatever model I want to run, naive Bayes, SVC, whatever tuning I need to do, whatever cross-validation, all of that just wraps around this pre-processing pipeline, and I can just say, go, right? And so I can do all of my normal stuff that I would do with a non-NLP project, but all of that's kind of like made possible by this pipeline that I've built. And so I can take this model, I can create a pipeline, I can slot in whatever pieces I want for my pipeline, and then it's just back to SkLearn again and stealing their brilliance by saying, you know what, fit, transform, fit. And then down here, fit, transform, predict. So by thinking about how we're stacking our pre-processing stuff together, we're now basically taking a lot of the onus off of the user, or in this case myself, so that I don't have as many chances to screw things up, is basically what it comes down to. I can say, at the top, build 25 different pipelines, do 25 different ways of feature extraction. I don't really care what they are once I've made some choices about them, but I want you to try as many as possible. And then once I'm down here, I can start doing things like looking at the score, looking at the behavior. I can measure accuracy. I can look at whatever metrics I care about that are at the end of the pipeline without having to manage the top end of the pipeline so much. So basically, there's sort of three major takeaways that I would argue that you can come from this. And let's say four. One of which is don't do it the way that I just did it. Like do it in a much better way. Make your code way cleaner than I will ever make my code because I'm lazy. But the other three are NLP does some really neat things, but I think everyone that's ever done it acknowledges that the process is messy and terrible. Like even if you think it's a glorious invention, at some point you have been swearing at your computer at 3 in the morning, threatening to throw it out a window if you're doing NLP. And so with some planning, it's possible to organize things into a consistent flow. And that's that idea of pipelines. And pipelines often get applied to like enterprise data, right? Like I'm working for a bank, I've got data flowing in, and I've got this pipeline to manage it and take it and do things. We often forget to apply that back to NLP. We often forget that, you know what, maybe if I take some time and organize how my data flows, it's going to save me hassle down the road. And then abstracting away a lot of that mess is also a very powerful tool. Because if I'm not spending all of my brain power on managing the pipeline, but I'm instead letting the code manage the pipeline for me, then all of a sudden I can really dive into the parts where I'm better suited to solve those problems. And so taking the time to think about your data pipeline, putting it into action, and making it abstract away the handling parts, I think is something that I haven't seen applied to NLP as much, and we really should be, as a community, starting to do that more. And with that, thank you very much, and I'll take some questions.
Any questions?
When you persist the pipelines to disk, do you persist like a trained version of your vectorizers? Or, I mean, ideally you'd want to leave that untrained for each new data set that you're passing through, right? Because everything else is deterministic, but that particular piece depends on your data set, right?
Right. So I think in this case, whenever I persist to data, it's after doing a fit, because I want to just load the pipeline directly into transformation, so later I don't have to relearn anything. But the choice there is really about like where do you do your fitting in your pipeline? Are you persisting this and then applying it to a bunch of data sets, or are you learning once, persisting it, and then only using it at the end to make your predictions or whatever you're doing? So I think either way could work just fine.
More questions?
Thank you. Really interesting. I like that. Just make sure that I kind of caught the intent. It sounds like the way that you've optimized it, machine learning folks, we often do hyperparameter optimization, but it seems like here that can be expanded out, and some of the pre-coded pipelines, the process, the different choices can also be part of just a hands-off optimization routine. Did I understand that correctly?
Yeah, so basically I looked at cross-validation and thought, wow, that's really nice. I wish I could do that with all of the pieces of, like, all the different tokenizers that I could try and see which works for my data. And so that was basically the idea was just, at some point we need to, and maybe somebody else has done this way better than I have, but we need to make that grid search ideology of let's optimize on what we have apply to both pre-processing and the modeling, not just the modeling.
Anyone else? All right, thank you, Zach.
Thank you.